Ionic compounds are when you have a metal plus a nonmetal. Those are ions, and those ions form an ionic bond, and we can write the chemical formula or write the chemical name. And ionic compounds in general have a lot more complexity. You've got the polyatomic ions, you've got the metal ions that can form more than one charge, you've got the stock system name, you've got the crossover rule. The one thing to remember about covalent compounds is that none of those are going to happen for writing the names or the formulas for covalent compounds. So there's no Roman numbers, there's no crossover rule, there's no ions. Covalent compounds are when atoms bond together. These would be two or more nonmetals, so you should never see a metal in a covalent compound. And they bond together by sharing electrons, and so that covalent compound is what I've been referring to, is when you have a molecule, the atoms are smushed together, they no longer have their individual boundaries. So for writing chemical names of covalent compounds, these prefixes are used, and these you might have already been familiar with, is these prefixes represent numbers of the atoms that are present in the covalent compound. So 1 is mono, and in this name N2O is the chemical formula. There are 2 nitrogens and 1 oxygen. The name of it, showing that there's 1 oxygen, has the mono prefix, monoxide. The 2 nitrogens are using the prefix di, which indicates there's 2 of those nitrogens. So this is all of those numbers. So mono, di, tri, tetra. This is on your memorization list or your cheat sheet, and these are only going to apply for covalent compounds. This is when you have 2 or more nonmetals bonded together. Never going to see these in ionic compound names, okay? The only complication for covalent compounds is there are a few common names that are used where you don't use the di, tri, tetra, mono for water. So water, the official name would be written dihydrogen monoxide, but it's actually not called that, it's called water. NH3 is not called mono, nitrogen, trihydride, it's called ammonia. Okay, so that's the common name, it's called ammonia, and it's important to note that it is very close to the polyatomic ion called ammonium, that's NH4+, but this is ammonia, that's just NH3. Okay, this is not called trioxide. This is called ozone. We saw that in the air pollutants. And then this CH4, not called carbon tetrahydride, but it has the common name methane. This is natural gas. It is what's in Bunsen burners or what heats homes, or if you have a gas stove at home, this is CH4. It's being picked in there. So this is, the prefixes are used to indicate how many of the atoms are present, and the prefix is a subscript in the chemical formula. And so this is an example of P2O5. So those are the subscripts, the 2 and the 5. They didn't come from any crossover rule. These are indicating how many atoms are present in this covalently bonded molecule. So diphosphorus, 2 phosphorus atoms, and then pentoxide, 5 oxygen atoms, all bound together, smushed together in covalent bonds. So CH4 is methane, and methane is actually the first in a series, a family of hydrocarbons. So hydrocarbons are compounds that have only hydrogen and carbon. And the carbon is listed first, the hydrogen is listed second in all of the chemical formulas of these hydrocarbons shown. So methane is the first in this family. The first 4 in this family, the number of carbons is indicated by a prefix that's not the same as the original prefixes I just showed you. Those are called Greek prefixes. The first 4 in the family go by a mnemonic that is mother eats peanut butter. MEPB. Mother eats peanut butter, which is 1, 2, 3, and 4 carbons in the chemical formula. So this is the first 4 in the family of hydrocarbons. So you can predict the number of carbons by the prefix name, and this is 1 carbon, and then the number of hydrogens can be predicted by using a simple formula that I will show you on the worksheet that we're going to do for covalent compound chemical formulas. But for naming hydrocarbons, you have the first four that are in addition to those Greek prefixes, where M is 1, E is 2, P is 3, and B is 4. And that's the number of carbons specifically only in a hydrocarbon compound. And the rest of these are similar. Pentane, hexane, and so on. Those are the 5, 6, and so on that you've seen for the Greek prefixes. So let's put this to work in this worksheet, covalent compound chemical formulas.